Hi, I'm Mr. McConley from Burnock's Westerlo General Physics class, and today we're going to do a lesson on constant velocity. So what I have here is my assistant, who's filming right now, is going to drive an ATV over a set distance of 60 meters, and we're going to figure out what constant velocity is all about. So, as I was saying, we have two objects, a chair, and then down this way, a post, and they're 60 meters apart. And so my assistant here is driving, and we are timing start. He's going his best to go at a constant velocity. And he stops the stopwatch. Then, on the return, it's going to be a little different. You'll notice what he does this time is he's going to vary his velocity. So the timer will start. He speeds up. Whoop, he's slowing down. Speeding up again. Slowing down. Slowing down. And stop. And what he was doing there is he covered the same distance. This time, he covered it in the same time also, but this time he was varying his velocity. Nice job. What was your time?
It was 10 seconds, both times.
All right, 10 seconds. I'm going to give the camera back to you. Just be careful not to hit the stop button there. Let me get my tab. So if you come around to my left-hand side. So, what we're talking about here is constant velocity, or what we say is average velocity in physics. So, the equation is simple. It's V for velocity is distance over time. So the V has a line over it, and this line, you may be familiar with from math class, means average. This is velocity. Velocity would be in meters per second. Our distance is in meters, and our time is in seconds. So, given what we just did, we covered a distance of 60 meters, and my assistant said that he did this in 10 seconds. So when we divide, 10 goes into 60, zeros cancel out. It goes in how many times, assistant?
6.
6 times. So you are going at 6 meters per second. That means every second you covered 6 meters of ground. Now, I want to talk a little bit about the difference in the two runs. So if you recall the first run, you can shine the camera at me. If you recall in the first run, the ATV traveled at a constant speed. So if we had taken what is called the instantaneous velocity at any moment, boom, we had like a radar gun, it would have been 6 meters per second. Check again, 6 meters per second. 6 meters per second, because we were going at a constant rate, a constant velocity. As he returned, coming back the other way, you notice he gave it the throttle, he sped up. He definitely went faster than 6 meters per second. He slowed back down, he sped up, he slowed back down, but in the end, he covered the same distance in the same amount of time. So in the end, when we do the math, it would come out exactly the same. It would say that his velocity was 6 meters per second, when in actuality, he might have never been going 6 meters per second. He was always going faster or slower and just crossing through 6 meters per second at certain given times. Now, the example I want to relate this to is driving on the thruway or a toll road. When you drive on a toll road, you could pull onto the highway at the exact same time as another person. You could be going pretty slow because you're a new driver and you're going to go real slow. You're just going along a little bit under the speed limit, put, and you're driving down that road. And the other driver goes tearing down the road, but then pulls off at the rest station, grabs himself a coffee, jumps back on the highway and goes tearing down the road again, and you guys actually get off at the next exit at the exact same time. Were you going the same speed? Well, most definitely not. But your average velocity would come out exactly the same. So average velocity can be deceptive and a little bit misleading, but it does tell you for a certain distance in a certain amount of time what the average speed was. So for today, that's our lesson on constant velocity. This is BKW